Do not watch this video unless you've tried pages 2 and 3 on series circuits on your own already. If you have done the work already, this is to help you check your work and for us to go over it. So on page 2 for number 1, the following circuit contains a set of 3 resistors connected to a 10-volt source of electrical potential. Letter A, calculate all of the unknown quantities. Use the chart to figure out the circuit. All right, so first of all, we need to look at the chart. The only thing that we have listed here is a 10-volt total voltage, which is my 10 volts right here, my battery. They also tell us R1, R2, R3, so we can go ahead and fill that in our chart. So 10 ohms, 20 ohms, and 50 ohms. The next thing that I should do is find my total resistance. So to do that, I use my R total formula, which is equal to R1 plus R2 plus R3. And if I add all of those up together, we will end up with 80 ohms. Okay. Next, so this will label them. So this should have been step 1. Step 2, I look to see what I can fill in here. And the only thing that I have as far as enough information to satisfy V equals IR is my REQ line. So I know that 10 volts is equal to I, which is what we're solving for, multiplied by 80 ohms. My total current, if you divide, should be 0.125 amperes. If you left it as 0.13, that's totally fine also. 0.125 amperes. I know that all of these are the same as far as my current because in a series circuit, current is constant always. Next, I can go through and I can fill in the remainder of my voltages using V equals IR for all of them. So if I use V equals IR for all of my voltages for R1, R2, and R3, you should end up with 1.25 volts, 2.5 volts, and 6.25 volts. If you add them together, you will get 10 volts total. The last column, this power here, I'm going to use P equals IV. So for the first one, if I have 0.125 amps multiplied by 1.25 volts, we will end up with 0.156 watts. Solving for the entire column, you should end up with 0.313 watts. Again, if you left it as 2 decimal points, totally fine. 0.781 watts, and the last one should be 1.25 watts. Okay. For letter B, you want to add an ammeter to your circuit. An ammeter, if you remember, must be placed in series. It has to be placed in series. It has to be on the same line as your wires, always. You can place an ammeter anywhere you really wanted to. If you wanted to place it over here, that would have been fine. If you wanted to place it over here, that would have been fine. If you wanted to place it over here, that would have been fine. It doesn't make a difference. All you needed was one. So you pick the spot. I'm going to leave it with my first one, which is right over there. And then letter C, add a voltmeter to your circuit that is going to read across R1. A voltmeter has to be placed parallel, which means it has to be placed on the outside of your circuit. So if I want to read across R1, that does not mean like across the way from R1. What it means is that it wants to read across R1, so across this resistor R1. If I'm adding a voltmeter, I have to add a voltmeter such that you have a little V inside. So if I get rid of, whoops, too big of an eraser there. If I get rid of this extra little wire there, your voltmeter should look like this. All right, so that is for page 2. If we move on to page 3, sketch a series circuit that conforms to the characteristics of the chart below. Use the standard circuit symbols from your reference table, and we want to calculate all of the missing quantities. All right, so the first thing that we see here, we have almost all of our resistances, so that's where we should start. So R total is equal to R1 plus R2 plus R3. R total we know is 150 ohms, which is equal to R1, which is what we're looking for, plus 10 ohms plus 70 ohms. If you solve for R1 using some algebra, you will end up with 70 ohms as your answer. Okay. The next thing that we can do, we want to find our current, and I know that I have enough information as far as R1 is concerned to be able to solve for my current, so I'm going to use V equals IR to do that. V equals IR given 5 volts is equal to I multiplied by 70 ohms. Solving for this, you will end up with I to be 0.071 amperes. And once I know my current, again, this is a series circuit, so I can go through and I can add in all of my current throughout the entire column here, because current will always be the same when we're talking about a series circuit. The next thing that we can do, we want to solve for the rest of our voltages. So using V equals IR, let's start at R2. We can go ahead and we can solve for all of them. So 0.071 multiplied by 10 should give us 0.71 volts for R2. If you do the same thing all the way down the column, you will end up with 5 volts for R3. And lastly, 10.65 volts as your total voltage for your circuit. If you go ahead and you solve for your powers, you can use any formula as we always do. Let's see if we, trying to see where to put it because I know it's a little bit dark on the page here, but this should be 0.36 watts. There we go. The next one, 0.05 watts. The third, 0.36 watts. Obviously, because your resistance should be the same, then your voltage, current, power, all of that should be the same as well. And then the last one, 0.76 watts as your answer. The last part of this asks you to draw a series circuit. So that is our last step. Let's zoom out so we can see what we have going on here. The first thing that we need to do always is start with the battery. So I'm going to start with my battery and I'm going to put it right over here. And my battery has to have wires that come out of it. Attached to this battery, we know that we have 1, 2, 3 resistances or resistors that have resistances. So I need to make sure that I have 3 resistances in my circuit. You could put them along the same line. You could put them separate. Does not make a difference. So I know that I have 1 resistor that I can put over here. I have another resistor that I can add in here. And then I'm going to put this last resistor right here on the bottom, because why not? And it looks like this. They tell us to calculate all of your quantities, and we want to draw a circuit. They don't ask us for any labels. They don't tell us that we have any ammeters or voltmeters. So truly,